good morning or good evening, whenever you're watching this video. We are going to move on to the second half of Unit 2 and get into human populations. Now, you may have heard me say that I think this is probably one of the most challenging units that we're going to be talking about all year, because this is where we jump into population math. And as you've already noticed from the previous section, that there are a lot of graphs. So you need to be very comfortable analyzing these graphs and doing the population math problems that I'm going to show you how to do. All right. So, question is, how many people do we have living on the planet? We have 7 billion people currently living on the planet. So this is how our population growth has changed. So you can see, starting right here, that throughout most of history, we've had very slow, stable population growth. Okay? Now, when we get to about here is where things start to change. So hopefully by looking at this, you guys have noticed that this is a J-shaped curve. All right, so in our last portion of the unit, we said that a J-shaped curve means, hopefully you remember, exponential growth. So the human population is currently experiencing exponential growth. All right. Here's the Black Plague. You probably have learned about this in your history classes, and it's a teeny tiny little dip, but obviously we recovered tremendously from that. Now, what's going to be interesting to see is when our current pandemic is over, how those population numbers are going to cause a change in this graph. I can't imagine it's going to be a major shift, but there could be a little tiny one. All right, so let's look at projections. So in 2030, so we're talking about 10 years from now. So in 2030, if we look at our current population growth trends, our population will hit 8.6 billion. That's only in 10 years, guys. In 2050, okay, based on our current trends, we're going to hit 9.8 billion. All right, and this is all within your lifetime. And then lastly, in the year 2100, it's projected that the human population will be 11.2 billion. So the question becomes, have we reached the current carrying capacity for humans on the planet? And which one of these years is going to be the carrying capacity for humans? Okay, that's a K, y'all. Remember, K is for carrying capacity. All right? So we look specifically at 4 factors that drive changes in human population growth. Well, the first one is obviously having babies, so we call that fertility. Now, fertility, the way that we analyze it in learning about human populations, is the total fertility rate. Okay, that is the TFR, total fertility rate. And what the total fertility rate is the average number of children born alive per woman. Okay? So the total fertility rate is the average number of children born alive per woman, and it is going to vary by country, by where that woman lives. And you'll see we're going to look at some examples of population pyramids here shortly that, depending on where you live, those total fertility rates are going to be very different from one another. Okay? All right, the second one that's causing a change in human population growth is life expectancy. Now, this one's kind of a no-brainer. We know that people are living much longer than they were 100 years ago, and it's because we have access to better health care for the most part. The third factor is age structure. So, age structure we're going to learn about when we talk about population pyramids, because it's going to show us what percentage of the population is within reproduction age and what percentage of the population is post-reproductive age. And that's going to be a very big impact on how much the population is changing. Our last one is migration. We mentioned this a little bit in the first set of notes from a previous video. Migration, so moving into or out of a country, is also going to impact how a population changes. All right, so let's get into the fun stuff now. All right, so here's our population math. Now, there are formulas that you guys are going to have to remember. The AP test is not going to give you a formula chart. Now, thankfully, most of these formulas are very easy to remember, and the math is very easy. So we're going to work out some example problems. But the first thing I want to do is to show you what these equations are and what they calculate. All right. So the first one we're going to look at is for what we call the crude birth rate. All right, the crude birth rate, the CBR. Okay. This is equal to the number of births divided by 1,000. All right, so that's going to give you the percentage of births per 1,000 people in a population. Now, on the other end of that, we can also look at the crude death rate. Guess what, guys? It is calculated the exact same way. So the crude death rate, the CDR, is the number of deaths per 1,000. Okay? All right. Now, what we want to look at is how we can use this to calculate our global change. We can calculate population change globally and locally. So let's start with the big picture first. So the global population growth rate. The global population growth rate. Okay, so remember, we have to look at births and deaths. Okay, so the global population growth rate is going to be the crude birth rate minus the crude death rate divided by 10. Okay? Now, the question is, why are we not putting immigration into this? Because I've told you before that when we're looking at the population growth of a country, that's the key word, country, we add in immigration. But why do we not add immigration here? Well, it's because people aren't immigrating from outer space into the planet Earth as far as we know. So we leave that out. All right? Now, we can also look at the population growth rate for a country. Okay? So the population growth rate is going to be equal to births minus deaths divided by the total population. Okay, so this is how we would calculate the population growth rate for the United States, for example. Okay, all right, so the big equation that they ask a lot about on the AP test is doubling time. Okay, so I'm going to kind of make a section over here, put a star next to this one, because this is one that gets asked on the AP test quite frequently. So doubling time. So you'll see questions phrase something like, how many years will it take the U.S. to double its population? How many years will it take Canada to double its population? Okay, so doubling time is equal to 0.7 divided by the growth rate. Okay, 0.7 divided by the growth rate. That gives you your doubling time. So the answer is going to be in years. Okay, now sometimes when they give you questions, you're going to have to calculate the population growth rate first and then use it to determine the doubling time. Okay, so these two equations are very dependent upon one another. You have to know the population growth rate in order to determine the doubling time. Okay, I will be working through some practice problems with you guys. I'll record myself doing those problems with you, and then you're going to be practicing some on your own. Okay, all right, the last thing that is on this page for us to talk about is the fertility in the 10 largest countries in the world. Okay, so what 3 countries have the highest population? All right, we know that China is the largest, India is second, and the United States is third. Okay, India will be passing China within the next few years. Okay, so fertility in the 10 largest countries. This is the children per woman. Okay, remember this is the total fertility rate. Okay, and as you can see, depending upon the country, that total fertility rate changes drastically. So Nigeria, obviously, women are having in between 5 and 6 children per household. All right, Japan, it's not even quite 2. Okay, so most people are just having 1 child. Now, where this comes into play is the replacement rate. So you get married, you have a family one day. In order for you and your spouse to be replaced, how many children would you have to have? And so that answer is 2. Okay, so the replacement rate is the number needed to keep the population stable. All right, so if it is a 2-parent household, then you need 2 children to essentially replace yourselves and keep the population stable. Okay, so equals 2. All right, so what we're going to look at in the next set of notes that are coming is population pyramids and how education levels can impact this total fertility rate right here.